What's up, guys? Welcome to Rotor Riot. I am Kevin, Stingersswarm, and today we are here to build the XHover Stingy frame. So we've got everything you're going to need. We got the Stinger frame, we got my tools, we have components, we even got a soldering iron over here. First things first, we have the frame. Now this is exactly what you guys are going to get shipped in the mail. What do we have? We got our carbon fiber. Let's get right in and we're going to show you all of them pieces. In your packaging, you have camera plates, a top plate, your main plate, the bottom plate, and we have arms. Now every single one of these carbon fiber pieces has chamfered edges, so there's not going to be any need to do any filing on this frame. As you can see, we're going to have the main plate, then you have arms, then you have the bottom plate below that, making a nice little sandwich. 20mm standoffs along with one standoff that goes in between the camera plates underneath the camera. Battery straps, stickers, landing pads, and a nice battery pad that we're going to get to later, but I don't want to open that up because I don't want to lose all these little bits. For this build, electronics-wise, I'm going with a Betaflight F3 board. This is what I've been flying in just about all of my setups lately. My favorite ESCs, the KISS 24 amp ESCs. The brand new XHover 2206 2420 kV motors. Look at that. These are pretty sweet. I've been flying them for a couple of weeks, liking them a lot. FR Sky XSR receiver, TBS Triumph VTX, and that Rotor Riot Runcam Swift. In terms of tools that you're going to be needing, you will definitely need a soldering iron for all of your wiring purposes. You are going to need a 2mm driver, some snips, and I like to use these little needle nose pliers to hold wires in place while I am doing some soldering, so I keep some of those handy. And just other little bits and bobs like electrical tape, double-sided sticky tape, little rubber standoffs instead of nylon. I prefer the rubber ones. That's pretty much all we're gonna need. Oh, I forgot to mention this. This is the secret sauce. Beautiful vinyl sticker that we are going to place on the frame. First things first, you can't put the thing together if it's not got the stickers on it. It is going to be much easier to pull the holes of the stickers off before applying it to the arms. Just get like an X-Acto knife, something with a good edge. Okay, so I popped out all of the holes ahead of time so that we don't have to do that after the fact while we're applying it to the arm. I find that if you just get it on here and kind of align the holes, boom, like 12 more stickers to go. It's a little bit tedious, but dang, it looks so pretty. Look at that.
It does. You can see the difference right now.
We have the black and white camo here, and as you notice on the top plate, it has stingers cut out. And so what I'm going to do right now is I'm going to peel off my little stinger cutouts from the camo, and I'm going to stick them on my toolbox because I think they look dope. Boom.
That box got stung.
I got the holes popped out on the top plate. Some of these holes, like these, are connected to the outside. You actually don't have to pull those out ahead of time. Good. All right, so we got our top plate done. We got our arms done. I'm going to get to sticking the stickers on, and we'll be right back to assemble the frame. What I've noticed after doing the entire stickering everything, it's much easier to actually lay these on and peel the holes off after, I think is my final word on that. I found it really easy to just line it up in these corners. And then you can take like a little hobby knife or something, get in here to pop out the little holes. Now we are ready to move on to assembling the frame. I'm not saying that this is the end-all be-all way to build a frame. I'm just showing you guys the way that I go about building the frame. So we've got all of our parts. They are fully sticker bombed here on the table, as you can see. And what I like to do is I like to get the main plate along with the arms assembled and the standoffs in place so that I know where all of the wiring needs to be routed, and then I can start building up from that point on. So what we're going to need is we're going to need our hardware, our titanium screws. The main plate has the, what do you call these, self-tapping nuts?
Press nuts.
Press nuts.
I think it's also worth mentioning that these are XHover versions because they're not, these are low profile. They've got a spiral attached to it. They're really nice.
On top of that, you can just put a nylon nut that's like 2mm tall, and it'll be enough separation from those nuts to put your PDB down. So we need our 2mm driver. Now, getting the first arm in place is always a little bit tricky. What I like to do is I'll go ahead and just put the screw through the hole on the very bottom plate. This should be the right arm. Yep. Come over here to the proper hole on the main plate. And I'm not going to tighten it down very tight. I'm just going to give it a little bit loose so that I can go ahead and get the other screw in for that one arm. Now we're just gonna do the same steps around with each of the 4 arms. And as you put more arms in, as they lock together in that center section, there's less and less room. You can see by the 4th one, it just has to go into its location. I'll slide the 2nd arm in here and just kind of gently screw it down. Once all 4 arms are in place, then that's when I go around and tighten up all of the bolts. All right, last arm. Now I'm just gonna go around and tighten up all of these bolts, make sure everything's nice and secure, and we will move on to installing some standoffs. All right, all the bolts are nice and tight now. I like to go mostly get all of my standoffs in so I know where the wires are going, the main plate, and then start putting in motors, ESCs, flight controllers. Install our standoffs. Spinning it from the shaft instead of from the handle comes in real handy, because you can see that is a lot of bolt that's exposed to grab into the standoff. Twist on the shaft and it'll screw down a lot faster. Save you some time. And the nice thing about these knurled standoffs is that you can grab them with the pliers and you don't end up stripping it and making really ugly marks all over your standoffs. Do try to be a little bit gentle. 20mm standoffs are installed. All that's left is going to be the top plate later for the frame, well, your camera plates too. But before we move on any further, I'm going to go ahead and install my little rubber standoffs. I am going to be using very little bolts to hold these on. The one thing about these rubber nubbins is you can see I've almost already run out of thread there. That's all the thread that there is. That leaves just enough for this main plate. So you do have to get, if you're going to use the nubbins that I have, you kind of need shorter screws. Now on these, if you use the rubber standoffs like I'm using, one thing to be really careful about is don't over tighten them. The first time I used one, I stripped the screws right out of the rubber and split it in 2. Tommy agrees.
I did the same exact thing.
All right, so I got all of my standoffs for the flight controller installed. So now we're gonna install the motors. If you look at the base plate on this motor, you've got a lot of room on this side between the windings and the base plate. And on the other side, there's not so much room. What I've found is that with 6mm standoffs, it gets into the base plate, but it doesn't come all the way through. And I like to have as much locking as possible. So what I'm gonna be doing is I'm gonna be using 8mm bolts on the section where there aren't wires directly over the base plate, and 6mm bolts on the section where there are wires above the base plate. First off, I'm going to start with an 8mm bolt. By the way, just about every mini quad motor out there is 16 by 19. That's because these two are 19mm apart, these two are 16. What I find is the easiest way to install the motors between the 19mm bolts first. And I put one on the 19, nice and loose. Grab a 6mm and come back here to the other side. And if you do the 19 by 19 first, you can go ahead and tighten those down because there's no wiggle room in the slots. You can see that because I did the 19 by 19 first, the 16mm spread is perfectly lined up with the holes. So we can just put those bolts in now. And so now we're just gonna go ahead and repeat that and put 3 more motors on this bad boy. All right, now at this point we have the main plate with your arms and your bottom plate and all my standoffs and the motors installed. For the most part, that is your hardware. Now I'm gonna start getting into some of the wiring, but before I do, it just kind of rattles around on the table and it annoys me. So I like to go ahead and put my little footsies on the quad at this point. Now, this could be a thing of fierce debate. Where to put the footsies? Do you put them in close or do you put them out wide? I personally like wide footsies, a nice wide stance. I'll butt it up against the bolts for the motors. Basically as wide as you can get without covering up your motor bolts. And then we'll have a nice stable platform to work on. Isn't gonna rattle all over the table on us. Look at that. Dude, I love these things so much. What I'm gonna do now is we're gonna start working on the electronics. So first things first is the Betaflight F3 board. Now, a lot of people complain about the layout of the Betaflight board with the wires on the bottom. And I'm not gonna lie, it's not the most convenient layout. But what I find is if you're gonna build and you plan out your build and do it in the right order, it's not that bad to have your positive and negative leads for the ESCs on the bottom. See, this is the flight controller, And as you can see on the bottom, we've got the leads for the ESCs. So what I'll do is I'll go ahead and put the wires for the ESCs onto the bottom, solder them on, and then we can mount it and start wiring everything else up. I'm gonna go ahead and tin the pads on the flight controller that we're gonna be working with. One thing to note with the Betaflight F3 board, there is a lot of metal on the ground side. It will suck the heat up. So for soldering, especially on the positive and negative side, I like to use my soldering iron at 400 degrees on this. With silicone wire, it's really easy to strip with just your fingers. I know a lot of you guys probably have fancy stripping tools or like to use your X-Acto knife, but just take your fingernails, grab it, boom, stripped. All right, so now this is where my handy little needle nose pliers come in. We're gonna do the positive first and then we'll get over there. Make contact with your pad, make contact with your wire, get both sides nice and hot, and you got a nice little connection there. Now to figure out exactly how long I want to trim it to, I'm just going to go ahead and place it. And that is going to be more than enough wire because we're going to have an ESC here. So I'm just going to trim it right here for now. That'll leave me plenty of room to work with for later. And now we're going to strip and repeat until we have positive and negative leads for all 4 ESCs. So we now have Betaflight F3 board with positive and negative leads for all of our ESCs. That is almost all of the things that go on the underside of the flight controller. Once I get the underside done, I'll usually just go ahead and bolt it down and work on it from there. But the last thing we have to do is the XT60. And the XT60 is very important to me. This is some of the heaviest wire on the quad. It costs you weight. So I try to make it just trimmed just right. Here's another quad that I have fully built up. As you can see, I bring kind of the XT60 up to the side so that it's at the side of the battery. Battery lead across, plug it in, good to go. So I'm gonna measure with the flight controller on its standoffs. So we're gonna come off of here, and we're gonna come around. I want it to come a little bit further forward. So right about there is where I want to cut my wires. And then snip, snip, strip, strip. And now we're done with the underside of the flight controller. I am ready to secure it to the build. I know that you're probably gonna say, Stingy, this is overkill. You don't need to double soft mount your flight controller, but this is what I do. I use the rubber standoffs and I put the little silicone O-rings on there as well. Get you one on each standoff, put the flight controller down, put another one on each standoff, and now nylon nuts. And I just kind of hand tighten these. Soft mounting flight controllers has the biggest effect on motor noise getting into the into your gyro. There, flight controllers locked in, and we are ready to start putting on these KISS 24 amp ESCs. Before I can actually put the ESC down, I like to insulate it from the carbon fiber. Now we do have these vinyl stickers, which is gonna help insulate it a little bit, but I'm still gonna go ahead and use the double-sided sticky tape because I feel like it kind of protects it in a crash when things get banged around. The width of the double-sided sticky tape I have is basically like a KISS 24 length. So I just kind of cut a little piece that's wide, just wide enough for the arm, and I'm gonna take a little piece of electrical tape to secure the ESC in place while I am soldering all the wires to it. I like to try to leave a little bit of wiggle room in case you break standoffs or have something where you need to move things around like the flight controller or a motor. If you have a little bit of extra wire, you can like lift the flight controller up. If you have everything cut perfectly to length when you go to do repairs, it's like, oh, nothing moves and you have to take the motors off and it's a pain. So I like a little bit of extra wiggle room, so I'll squish that back in about so. And snip it. Once you've trimmed it, you gotta tin the wire. All that boring stuff that you do a million times per build. If you look here, you got your ground pad, which is right next to the current sensor. That's not a current sensor. Mm-hmm. That's a current sensor? Okay, cut next to this guy. And
and it's called a?
No! If you do take a multimeter and do a continuity test between the ground and that end of the current sensor, you'll see that they're directly connected. So even if, like on this guy, see how I have this huge glob of solder that's covering that up? Big blob of solder, doesn't matter. Now, we've got the ground and the positive. We got some wire cha for connecting our signal and ground wires with. And now, if you're doing like me and you have the same color on your signal and ground wire, just make sure you do it right. Otherwise, it's not it won't be good. And that's it. So now we're gonna solder on the motor wires, and we're not gonna worry about crossing the wires. We're just gonna do them straight across. KISS 24s have a nice little reverse tab. All you gotta do is short it out, and we'll do that after the fact. And that is one ESC soldered in place. Now we're just gonna repeat for the 3 other ESCs, and then we're going to move on to getting our receiver and FPV gear wired in. Now that we have all of our ESCs fully connected and wired up, we're going to check and make sure 2 of them are going to spin in the right direction, 2 of them are going to be spinning backwards, but you have this nice little reverse jumper here, and so the 2 that are going the wrong way, we're going to just solder that jumper shut. So let's get right into that configurator. No props. No props. If it's USB and battery, no props. Wrong. Good. Good. Wrong. So these 2. There we go. All good. So motor direction is set. We're good with the soldering iron for the moment. Now, let me put the laptop away. So while everything is out here and exposed and easy to get at, that's when I like to go ahead and wrap up my ESCs. And what I use for ESC protection is a piece of busted prop. I learned this actually from Tommy. All you gotta do is you take a piece of prop and electrical tape. I make sure that the leading edge where the props are coming in is gonna get protected. ESCs are wrapped. We got that protection. We all wrapped up like a Jimmy hat. So now it's time to set up our FPV gear and our receiver. So obviously the camera is gonna go right here, so we know that we need the wire for the camera, which is going to be this guy. We're going to need about that much length. The receiver, I mount right here. We know about how much length of wire we're going to take there. And on the VTX, we'll go on the underside of the top plate. The VTX wire just needs to go to the top plate, so it doesn't have hardly any room to travel at all. So now all I'm going to do is solder the connectors for those 3 components onto the flight controller. And I never can remember the layout on this board, so I pull up the diagram every time. Now, one other quick thing to point out. As I said before, the ground rail on the Betaflight F3 board takes a lot of heat. And so what I've taken to doing here is just filling in all of the ground holes ahead of time, and instead of putting the wire through the hole, just dipping it in to that little solder puddle. I can do the through hole just fine on all the other connectors, but for some reason the ground, that just seems to work better. I basically turn those through holes into a pad. Camera connector first. It's going to the top row. I'm not going to finish all the connectors for the camera first because the camera wires are going to go to the 2nd row down, and so since I'm going to go ahead and do the VTX and get that entire 1st row filled so that I'm just building back towards myself and not having to solder between the wires and all that. VTX connector ought to be about right there, give or take a little bit. Oh, but you know what? Okay, so this is what happens when you build. Some things go perfectly to plan. Sometimes you just forget about something. Like the fact that the smart audio needs to go all the way back to the back here. But what I can do is I can pull that smart audio wire out and replace it with the 5-volt wire that I pulled out of it a minute ago. So I'll do that.
Got it.
All right, so there's the white one that's now too short. We'll replace it with this red guy here. And there. So now that red wire is our smart audio wire. So that was the ground wire for the VTX. Now we're going to do the positive, and now the video out. Perfect. Left to right. We have the video in, which goes to the camera. Then video out, that is the VTX. Then this is connected. Oh my God, you know what I forgot to do? What? This is the RAM voltage.
I know what you forgot.
And this is the ground.
Yeah, I know what you forgot.
I totally forgot. On the underside, there are jumpers. Oh, that's such a pain.
All right.
We're diving right in.
All right. We're just going to go straight in.
Oh, man. I can't believe I forgot that. Okay, this is where I got to get a little bit creative. We've taken the flight controller off of the standoffs, and I've kind of gotten it all cockeyed so you can see in there. There are little jumper pads right next to that current sensor, which I found out what those things look like today. All right, come hold the camera now. Boys and girls at home, this should be your first step of soldering this flight controller, is to do these jumpers. Either you're going to need 5 volts for your receiver or 3 volts, depending on whether you're a Spectrum satellite guy or a Tyrannus guy like me. I need 5 volts. And for the VTX, since I'm running the high voltage Unify, I am doing the VBAT. So I'm going to solder those jumpers on the other side. And if you look right here, this is where those two jumpers are.
Put a diagram like right around right here.
Ooh, I'm losing O-rings. I should read 5 volts. 5 volts. Yay!
And we're back.
So we have the wires for the VTX connected other than the smart audio. We have the video connected for the FPV camera. We're going to now connect the 5 volt and the ground for the video camera. All right, now we need the receiver connectors. Now the receiver goes onto the bottom rail here. I always get this backwards because forever signal wire was yellow, but this one goes ground, positive, telemetry, and then S-bus. The connector is going to be about right here. We're going to be right there. That's plenty of wire.
So the reason why he's not doing this with his fingernails is because these aren't silicone wires.
Yeah, these are crappy wires. People, when you're soldering things, try to solder the furthest thing from you first. It usually works out way better than going the other way like I just did. The 2 wires that we have left, these are actually optional, but it's some of my favorite features for the Betaflight board and Betaflight in general. Number 1 is telemetry. So all of those current sensors, the milliamp hours drawn, the voltage of your battery, the RSSI, everything that can be good in your OSD, I like to have in the radio because I don't always look at the corners of my screen for the OSD. So I like it coming back to the radio and getting audio alerts. So I wire up telemetry on my receiver. Then we have smart audio on the Tramp, which is going to allow us to change the video transmitter's channels, power output, all sorts of cool stuff in the OSD, and makes it super handy. So I wire both of those up on these rear TXs. So right here we have telemetry for the receiver. I'm gonna wire it up to TX1. Quick continuity test because these are like so close to that ground. Make sure I didn't short them out and we're good. Now we have smart audio on the other side. And you're gonna have to set this up in software. You could have it the other way around just as easily. This is telemetry for the receiver. This is smart audio for the Unify. Right here we have S-bus, 5 volt for the receiver and ground. This is the 5 volt for the video, for the FPV camera. Ground for the FPV camera. Ground for the Unify. VBAT for the Unify. Video out to the video transmitter and video in from the camera. We got our motors mounted, we got the ESCs wired up, the flight controller is fully wired, we have the connectors for our FPV camera, our VTX, and our receiver. All we got to do is start mounting all of the little components, your FPV camera, your VTX, and your receiver, and get the antennas placed and everything, and then we're basically done. Next up, we're going to mount the FPV camera. This frame is built around the Runcam Swift, and the Runcam Swift 2, and the Rotor Riot Runcam Swift, but there's slight differences in the cases of those 3 cameras. The Runcam Swift 2 is just a couple millimeters wider. Now, you can totally just mount it with a regular Runcam Swift or a Rotor Riot Swift, and it's fine, but I find that it kind of bends those camera plates. So what I do as a little hack, a lot of us have these O-rings laying around. I just throw an O-ring right there on the sides of the camera. And it also adds a little bit of softening. It helps hold the camera in place a little bit more. All kinds of good things. I'm not gonna really tighten it up that much right now. I initially tried putting it on the back one too, but I found that it's, number 1, it's a pain to get the O-ring in place on the back one. And number 2, it doesn't matter if there's a little bit of an air gap between those two as long as it's holding enough pressure so that the camera doesn't move. That screw that goes into the back plate is what's going to allow you to be able to lock down your camera angle. We're not putting them in really tight right now, just enough to kind of hold it in place. We have this section, which is going to go through the main plate. We left it loose so that we got a little bit of wiggle room here. We're in. And now I'm going to go ahead and install the standoff that goes between the 2 camera plates. I tighten all the camera stuff down only after I put the top plate on. I will, however, go ahead and plug that bad boy in so I don't forget it, because I do that a lot. We're going to move on real quick to the top plate, because on our top plate we're going to mount the VTX and the antenna here. The VTX is going to just go kind of like that, nice and center. The antenna I like to line up so that it's coming out the back. I've already got the double-sided sticky tape on the VTX side. I am going to put some double-sided sticky tape on the antenna side here, just to add insulation so that the exterior of that antenna isn't touching the frame. It makes a little bit of a difference in your video signal. Now, as you notice, this section sits up higher than this, so what I'll do is I will double up on section that sits lower, and that'll help keep it from moving. And now, as you see, and I end up putting my battery strap right there between the leads. We're gonna zip tie this bad boy in. Hit it with a couple zip ties, just because it helps keep everything from moving, and it also ensures that when you crash, because I'm gonna crash, you're not putting stress on any of this stuff. It's all stressing the zip ties, and we should be able to fit a zip tie around the VTX so that it does not move any between the stingers. And with that, our VTX is all mounted. Top plate is almost ready. It's just going to need a GoPro mount and a battery pad. Now we can move on to our receiver. Look, I already got the sticky tape ready. This is an XSR. I do trim my XSR antennas so that they are quarter wave. I did chop this one off accidentally while trimming, and so it's a little bit short, but it works out for the way that I like to mount my antennas anyways, so it's not even that big of a deal. We're gonna go ahead and plug it in, and I'm just gonna try to get it as far forward as I kind of can with that XT60 leading the way. That's gonna work. And I'm gonna go ahead, we're gonna do a little antenna mounting prep here. I'm just making a loop to be the first piece. So this zip tie we're gonna attach the antenna to as it comes out the back. We're gonna end up attaching this guy right here, heat shrink, which will go about to here. Let's hit that bad boy up with a heat gun. Now, I like to do 2 zip ties holding this guy down. I've done it with just the one before, and it's pretty sturdy, but it flops a lot more, and it finds itself in the props a little bit more often. So I try to just hit it with 2, just like I do on the other one. Boom, 1 antenna mounted. Now, your antennas for polarization, you have vertical and horizontal. If you have 2 antennas sticking up, then you're not getting 2 types of polarization. If you do this, you get 2 types. If you do that, then you get 2 types. You just need them at a 90-degree angle from each other. So what we're going to do is we're going to have one coming off the back, and we're going to have one coming up the top. It is going to be very similarly mounted with the heat shrink and zip tie to this side standoff right here. I like to try to keep it to where the only the exposed part is above the top plate. That's close enough. Let's take this guy here, clip it right at the length of the antenna. This guy, and get them to where they're both right there about the end. What I like to do is I like to get the bottom zip tie on first, and then I don't do the top zip tie until after I put the top plate on, because if there's no top plate on, it keeps going vertical, and it's weird when you mount the top plate. If the top plate is on and you put it in there, it'll cinch it and it'll just cock it out a little bit, which is what you want, just a little bit away so it's coming away from the battery. So you can go ahead and make your loop so you're not fighting with the antenna, and then just kind of stick that right in there, just like so. The bottom zip tie is just wrapped around the zip tie that is connected to the antenna with heat shrink. All right, so that's basically it. We're gonna plug in our VTX. Before we go any further, let's make sure we have video, and we'll bind the receiver. I got it.
Ooh, got that green light.
0 volts.
And we're connected, so we're bound. If you want to set your receiver so that the failsafe is no pulses, go ahead and turn your radio off, plug your XT60 in, power your receiver up, and while it's on and you see it's blinking, there's no connection, we're just going to briefly hit the bind button. Boom, you see you got the little green flash. Now the failsafe on the receiver end is set to where it won't send any signal to the flight controller. It kind of helps the flight controller recognize a failsafe as early as possible. Now we will screw down our top plate. There we go. So there's the camera plates aligned. Normally, in such a scenario, I would start with the front so that it's holding the camera plates in place. But this time, I'm gonna toss them on the back first. The reason for that is we are gonna use the 3D printed GoPro mount, which is currently zip tied to our rig.
Just goes to show you how universal this mount is.
Today's B-roll brought to you by Brain 3D. I've gotten a lot of questions about the 3D printed camera mounts. I don't think they're in the Rotor Riot store. We should fix that. But there are more 3D printed components available for the Stingy frame, including like arm end protectors, soft mounts, comm docks, you name it. He's got all sorts of stuff that you can find at Brain 3D. And we have our top plate installed. Just a couple of things left to do. Remember how earlier we didn't tighten up everything on the camera mount? We're gonna go ahead and do that now. I'm gonna start off with my standoff on the bottom. And the reason I wait for that is because the camera plates, they'll wiggle a little bit, and you want to be able to make sure you get it all in the slot and everything is properly fitted. And it's easier if you just wait until afterwards. Now for my my FPV camera angle, I like about 45 degrees, so like right about there. Lock down these bad boys. And now, that camera, it's not gonna move. We need to finish the antenna mount. Remember how I said I like to wait until after the top plate is on? You can see right here how it's got a little bit of an air gap there. So I pull my little zip tie in. I think I hit the trash can.
Swish!
And so that is all of that mounted. Now the battery pad. Once again, we had the little Stingy cutouts. So the battery pad is designed to cover an extensive area of the top plate. This quad, if you have no GoPro, you're gonna end up with your battery sitting in the center section. If you have a GoPro as far forward as the 3D print puts it, you're gonna have your battery almost all the way at the back. If you do a foam wedge, like I did before, it sits a little bit further forward. Now, this battery pad is great, but I can save like 5 grams by not using the entire battery pad. And I like being as light as possible. So what I do is I take a little X-Acto knife here. I know, Daniel, I'm chopping your work of art all to pieces. So now, all of this, I'm not gonna use. You can trim it and use it on other things. If you have to replace top plates or something at some point, you got a little bit of extra battery pad, you can use it on another build. So now, I use this little piece. We'll go on this side. The first time I did this, I used the entire battery pad and then came back to it after the fact and trimmed off everything that wasn't really contacting the battery and made it as light as possible around that. And look, it just fits in with the camouflage. I kind of dig that look. Like I said, if you want to use the whole, if weight is not your concern and you want to use the whole battery pad, maybe sometimes you run a GoPro, sometimes you don't. In that case, I would recommend using the whole battery pad. Just for me, I'm always running a GoPro, so I just trim it down to where there's contact with the battery. So there's a little bit of a gap between the top plate and the extension cable for the antenna that's connected to the VTX. And I just slide my battery strap right in between those two, only going around the carbon fiber. Perfect. We have a battery, set it right here. Put the XT60 in my battery strap, like so. Let's just throw this GoPro in here for weight. Boom. That ought to just about center. Yeah, give or take a little bit. Now everything is assembled. We've got a battery mounted, we got the GoPro on the front. I set the failsafe on the receiver to do no pulses, and before I fly or put props on any quad, I personally do a failsafe test. So here we go. We got everything on and armed, and give it a little bit of throttle, radio off. Boom, perfect. It is not gonna cut people's. All right, so the next things that I'm gonna test is I'm gonna get into the OSD and I'm gonna get the video transmitter on the channel and power output that I prefer, and I'm going to put some props on it, and we're gonna do a test hover right out in front of the shop. Fully assembled, I got a set of props on. They are all the right direction, so it's not gonna go. We're gonna do a quick test hover to make sure that everything is in good working order, and then we're gonna call this build complete. Feels like a Stingy. Whoa, power lines. The build is complete. I hope you guys enjoyed this, getting to see all of the ins and outs about how I put one of my personal quads together. Please hit that like button, subscribe, come check out more content. We're always going to cool places, doing cool builds, covering the newest technology that's coming out for mini quads. All right, thanks. We'll see you guys next time. Now, every time he turns the camera at himself, Christian, you need to just flash in big letters with exclamation marks, "More, oh my God!"
I actually like that. Let's do that.